Okay, so we are going with refraction through a prism. See here quickly. ABC is a prism. AB and AC are refracting surfaces. BC is the base of the prism. Now, N1 is a normal to the surface AB, and N2 is the normal to the surface AC. PQ is the incident ray. QR is the refracted ray. RS is the emergent ray. Now, here I is the angle of incidence, R1 is the angle of refraction, R1, R2 are the angle of refraction, E is the angle of emergence. Now, if you look at this line carefully, so this is the incident ray and this is the emergent ray. That means we are extending the incident ray and the extended ray backward. So they meet at a point that it makes an angle that is delta. So delta is said to be angle of deviation. Angle of deviation is the angle between the incident ray and the emergent ray. Now, so we started with the quadrilateral AQNR. The sum of the angles in a quadrilateral is 360 degrees. So because these two are normals, so angle A plus angle QNR is 180 degrees. We wrote here. Second one, sum of the angles in a triangle QNR is how much? 180 degrees. Then we got again the second equation. Now, by solving first and second equation we came to a conclusion. Angle A is equal to R1 plus R2. So we came to conclusion here, exterior angle is equal to sum of two interior opposite angles. Now, delta equal to what? Delta, this angle, exterior angle is equal to sum of two interior angles. This angle plus this angle. Means what? That is, this value is I minus R1 and this value is E minus R2. So now take minus common there, R1 plus R2 you will get. But R1 plus R2 is A. So therefore, delta equal to I plus E minus A. Is that clear? Or we can also write I plus E is equal to A plus delta. This is the first equation. Is it clear, all of you? Is it clear?
Yes, sir.
Yes, sir.
Now we are going with the next one, the second part of the derivation. See, what is the light we have taken here? Is it monochromatic or polychromatic?
Polychromatic.
Yes, Dhruti. Is it monochromatic or polychromatic?
Monochromatic, right?
Ashant, what do you think? Is it monochromatic or polychromatic?
Sir, monochromatic.
What is a mono meaning?
Sir, it's only single line, right?
Yeah. Monochromatic means, okay, having single wavelength. Okay. Monochromatic means having single wavelength. Okay. So best example for this is sodium vapor lamp. Sodium vapor lamp. Second one is polychromatic source. So polychromatic is what? Multiple wavelength. Multiple wavelength, that is, we can write mercury vapor lamp. See, so we are using only monochromatic light. We are not using polychromatic. If it was polychromatic, then there will be 7 colors here at the emergent side. Dispersion will take place. Now, in this situation, what happens is when we are increasing, see the line. Example, this is the surface of the prism. So the light is like a line. It's not like a ray will be like a line. A straight line will be there here on the screen on the surface of the prism. So when you are changing the incident angle, the ray starts moving like this. But what will happen even if you are rotating the or moving the prism, so at a particular angle it starts coming back. Even though you are increasing the angle, but instead of increasing, it's coming back. So this particular situation is known as minimum deviation position. That is known as minimum deviation position. In minimum deviation position, what will happen? Minimum deviation position. In minimum deviation position, what will happen? So this is said to be delta M. This delta will be equal to delta M. Okay, in that case, what will happen? Angle R1 will become equal to angle R2, and I will become equal to E. Okay, refracted ray will become parallel to the base of prism. Refracted ray becomes parallel to the base of the prism. Base of the prism. Refracted ray will become parallel to the base of the prism. Is that clear? Now, so in that case, what will happen? I plus E is equal to A plus delta, right? So what will happen now? I plus I, this will become I plus I, which will be equal to A plus dm, delta M. So delta M equal to how much? 2I minus A. This is the formula, next formula. Delta M is equal to 2I minus A. This is the formula. Now, next one, what we have? I is equal to what? We have here A is equal to what? Angle A equal to R1 plus R2, right? So that will become, A will become equal to 2R, implies R is equal to A by 2. Now, if you go to refractive index formula, what is that? That is mu is equal, N is equal to sin I by sin R. N equal to sin I by sin R. What is I here? Here in this case, if you take I will be equal to A plus dm by 2. So I is A plus delta M divided by 2 divided by sin A by 2. So this is the formula for refractive index. Is that clear? This is the formula for refractive index. Is that clear?
Yes, sir.
Yes, sir.
Okay, just go through once quickly. If you have any doubts, ask me. In that minimum deviation position, what will happen? Delta is equal to delta M, and R1 is equal to R2. Angle I is equal to angle of emergence. So refracted ray becomes parallel to the base of the prism. Is that clear? Here, in this case, refracted ray will become parallel to the base of the prism. And what will happen here? Angle I and angle E both are equal. Angle R1 and angle R2 both are equal. Clear? R1 and R2 are equal. I and E both are equal. So what I wrote here, instead of writing I plus E is equal to A plus delta, I wrote I plus I. So in the minimum deviation position, what is happening? The refracted ray will become parallel to the base of the prism. Angle of incidence will be equal to angle of emergence. Angle of refraction R1 will become equal to R2. So this happens in the minimum deviation position. So refracted ray will become parallel to the base of the prism. Okay. Now what will happen now? I plus I will become 2I. So A plus 2I equal to A plus delta M, or delta M is equal to 2I minus A. So I is equal to A plus delta M by 2. Now here next one is what? A is equal to what? R1 plus R2. A is equal to 2R, or R is equal to A by 2. And refractive index formula is what? N is equal to sin A by sin R. Here sin of A plus delta M by 2 divided by sin of A by 2. This is the formula for refractive index. Is that clear? Is it clear? So
Yes,
we came across how many formulas? This is the first formula. This one is the second formula. This one is second formula. And this one is the third formula. Okay. Sin of A plus dm by 2 divided by sin A by 2. This formula is the third one. Now we'll solve a numerical based on this. Then we'll quickly move to the next concept. And before going to the next concept, let me draw the diagram also, there's one more here. We have to discuss that also. dm is equal to refractive index of second medium with respect to first medium. See here, n to 1. Now, monochromatic light means what? It is single wavelength. Single wavelength means sodium vapor lamp. I told you in the street lighting system, we use sodium vapor lamp. We don't use tube lights. Why so? Why we don't use tube lights? Why don't we use tube lights?
Because the light doesn't pass through a fog.
See, if you are using tube light, I told no, when there is a fog or when there is rain, then what happens? Like the white light will disperse through that water droplet or the fog, and the front vehicle you can see in 7 different colors. Dispersion will take place. So that is the reason we are not using polychromatic sources. We are using monochromatic source. Is that clear? Monochromatic means sodium vapor lamp. Now, if the angle is very, very small, if the angle is very small, I'm erasing this, okay? If the angle is very small, what do we write here? So if angle is very small, we write here, that is n21 is equal to what? We are removing the angle of A plus delta M divided by 2 divided by A by 2. Okay. So what will happen? These two and these two will go away. N21 is equal to what? A plus delta M divided by A. Okay. So then what do we get now? N21 equal to what? 1 plus delta M or I will, yeah, 1 plus delta M divided by A. Or we can write here dm is equal to, I'll not write like this. So N1, N21 into capital A, which is equal to A plus delta M. What is capital A here? What is capital A? Can anyone say what is capital A here? Capital A is the angle of the prism.
Angle of prism.
It is the angle of prism. This one. This is said to be angle of prism. Mostly if it is an equilateral prism, then it will be 60 degrees. Okay. So we got in one more relation. There are how many relations now? 4 relations. First relation, second relation, third relation, and this is the fourth relation. If the angles are small, N21 is equal to A plus delta M by 2 divided by A by 2. N21 is equal to A plus delta M by A. 2 and 2 will go away. Cross multiply this and bring this A on the other end. So plus will become minus and then take A common. We are left with this answer. Is that clear? Is it clear of you?
Yes, sir.
Okay.
Yes, sir.
I'm going to do a numerical now. So here it is. The numerical is 9.6 from the exercise. From the exercise, it is 9.6. A prism is made of glass. Go to page number 346, please. All of you. If you have the textbook with you, please go to page number 346. Go to page number 346. Question number 9.6. A prism is made of glass of unknown refractive index. We don't know what is the refractive index. A prism, a parallel beam of light is incident on a face of the prism. The angle of minimum deviation is measured to be 40 degrees. What is the refractive index of the prism? Material of the prism. The refracting angle of the prism is 60 degrees. If the prism is placed in water refractive index, predict the angle of minimum deviation of a parallel beam of light. Okay. So we'll start this numerical. Okay. 9.6. See, this is very, very important. Why it is important? Even he may ask a derivation, or he can go with a numerical also. And before going to that, I would like to draw the graph also. The graph, before going to that, I'll draw the graph also for angle of minimum deviation. Angle of minimum deviation. So this is angle of, so we have angle of incidence. Angle of incidence, which is I, and angle of deviation delta. Angle of deviation. Angle of deviation delta. Okay. So what will happen? So this is 0. I'm taking 0, 20 degree, 40 degree, 60 degree, 80 degree. Next one here, 30, 40, 50, 60. This is 30, 40, 50, then 60. Now, so what happens here? Somewhere around here, somewhere at 42 something. So it comes something like this. So this angle is said to be angle of minimum deviation. It comes around something like this. This angle is said to be angle of deviation. Is that clear? Angle of deviation delta, angle of minimum deviation. Here at this point, what is happening? Angle of incidence and angle of emergence, both are becoming equal. Is this clear? This graph is important. And we do this experiment also in the lab. And we also plot this graph also. Okay. Is that clear? So we take, at least we need to take 3 to 4 angles. At least 3 to, like you take 30, 40, 50 and 60 and try this experiment. So you'll get this graph. If you take only 25, 30, 35, 40, you'll get only this line. You won't get the other line. Okay. Is it clear, all of you?
Yes, sir.
Yes, Mr. Ahmed, are you there?
Yes, sir.
Yeah. Did you understand this one?
Yes, sir.
Okay, maybe because you are not there from the beginning. So anyways, no need to worry. So the class recording is available. I will just send it to you so you can watch the class recording. Now we will solve this question quickly. the question number 9.6. Then I can go to the telescopes and microscopes also. So a prism is made of glass. 9 points. This is 9.6. A prism is made of glass of unknown refractive index. A parallel beam of light is incident on a face of prism. Now the angle of minimum deviation is measured. How much? Delta m equal to 40 degrees. It is measured like this. It's measured like this. What is the refractive index of the material of the prism? It's asking what is n21 equal to how much? What is the formula for this? N21 is equal to, we had just now we did, right? So dm is equal to what? dm equal to n21 minus 1 into a. Did he mention any equilateral prism? No.
Sir, they've mentioned that A is 60 degrees.
Did he mention that? Yeah, it is mentioned. The refracting angle of a prism is 60 degrees. But that is the second part of the lesson, right? The angle of minimum deviation is 40. What is the refractive index of the material of prism? The refracting angle of the prism is 60 degrees. So what will happen in this case? Refracting angle is R1 is equal to R2 is equal to 60 degrees, right? R1, R2 is 60 degrees. The refracting angle of a prism 60 degrees. 60 degrees. If the prism is placed, predict the okay. So we got this one. So how will we do this now? So can we do using this formula now? A is equal to what? R1 plus R2, right? A equal to 120 degrees. Is it 120? A equal to angle of refracting angle of the prism. So we will take 120 and see whether we will get the answer or not. 40 degree. That is what? 40 is equal to how much? N21 minus 1 into 120 degree. Can you solve it now? So it will become N21 minus 1 equal to what? 40 by 120. So 4 ones, 4 3 is 12. So N21 is equal to what? 1 by 3 plus 1. So what will be the answer? 1 plus 1 by 3 will become 1.33, right? So it's coming for water, right? Then for the second case, I think. 1 second. 9.6. It is coming around. DM is equal to 1.53. And DM is angle of the prism. Okay. So we'll take it as angle of prism as 1 second. Just. See here, he gives the values. Delta M value is equal to how much? Delta M value is, the delta M value is 40 degrees. And he gives angle of the prism is 60 degrees. Okay. Angle of the prism is 60 degrees. So we just substitute in the formula. And mu is equal to sine of A plus dm by 2 divided by sine A by 2. So what do we get now? Mu is equal to sine of 100, 60 plus 40, 100. 100 by 2 will become 50 divided by sine 30. Okay. So what do we get now? Mu is equal to sine 50 by sine 30. Okay. Mu is equal to sine 50 by sine 30. What is sine 50? Can you solve it and tell me the answer? Can you check with the calculator and tell me the answer for sine 50?
Zero 0.7.
0.7. 7. That's it. 0.7. That's it. And this is 0.5.
I'm getting 0.766.
76. Okay. Just divide it. You will get around 0.76 by 0.5 will become 1.53. Okay. This is the refractive index. The second one he says refractive index mu is equal to what? For the second material, second case. Okay. We get here mu is equal to, now there is a, the same prism is placed in water now. The prism is placed in water. He is asking what will be the that is angle of minimum deviation. Angle of minimum deviation in the second case. So the refractive index, we know that refractive index of glass is 1.532 and refractive index of water is already given, that is 1.33. And he says, what is the formula now? Mu G divided by mu W. Mu G divided by mu W equal to what? Sine of A plus delta M divided by 2 divided by sine A by 2. So what we have to find out here? We have to find out delta M equal to how much in this case. We have to find out what is delta M in this case. So mu G is how much? 1.532 divided by 1.33 equal to sine of A plus dm by 2. 60 plus dm by 2 divided by sine 60 by 2 is 30. So now 1.532, can you divide it? 1.532 divided by 1.33. What will be the answer? 1.532 divided by 1.33. divided by 1.33. What will be the value?
1.15.
1.15. 1.15 is equal to how much? Sine of 30 plus dm by 2. Sine 30 is 1 by 2, 0.5. Okay, we will multiply this now. Sine 30 plus dm by 2 equal to how much? When you multiply 1.15 with 0.5, how much it is? How much is the value?
0.57.
0.57 you got, right? Now, 0.57 you got. Now, what we are going to do now? We are going to solve it now, this value. So, so how much it will be? 30 plus dm by 2 equal to how much? Sine inverse of 0.57. Can you find out the sine inverse of 0.57 value? Can you find out the value of sine inverse 0.57?
34.75.
34.75. So 30 plus dm by 2 is equal to 34.75. Okay, we'll bring this on the other side now. So how much it will become? Dm by 2 equal to, that will become 4.75. When we bring this 30 on the other side, plus will become minus and you subtract it. So dm equal to how much? 4.75 multiplied to 2. So that will become dm is equal to how much? 9.5 degrees. Understood? So this is the answer. Once again from the beginning, see here the problem says that the minimum deviation position of a prism is 40 degrees. Angle of the prism is given 60 degrees. Use this formula mu is equal to sine of a plus dm by 2 by sine a by 2 to find out the first part is to find out the refractive index. What is the refractive index of the material? Glass. Now, when we substituted this, 40 plus 60 will become 100. 100 by 2 will become 50. And 60 by 2 will become 30. Sine 50 value is 0.76 and sine 30 value is 0.5. Divided, you will get the answer for mu. Once you are done with this, we have mu g value and mu w value. Mu g by mu w is sine of a plus dm by 2 by sine a by 2. So 1.532 divided by 1.33, which is equal to sine of 60 plus dm by 2 divided by sine 30. Now divide these two values, you got this one and we got this one, sine 30. Cross multiply, we got this one. Bring this sine on the other side, it will become sine inverse. Now sine inverse of this value is 34 degrees or 0.5. Then take this 30 on the other side, plus will become minus. Cross multiply, you'll get the answer. Is that clear? Is it clear?
Yes, sir.
Okay. Please copy this, then we'll go to the next one. Yeah.